Hello and welcome to this video on building a live streaming app using React. Now, when it comes to live streaming apps, you always have two sides, the broadcaster and the viewer. And today we want to build both and bring them together. So let's first take a look at what we are going to build today in this demo. So on the left here, we have our broadcasting application. You see myself in here. And on the right, we have the consumer or the viewer. And you can see if we refresh, nothing happens because the stream is not live yet. It is in a backstage mode, and we'll get to what that means in a second. But if I now start the live stream and we refresh here, we can see it's building up. We have a timer running that you can see here, how long the stream takes. We see that two people are live in here. We see the same reflected here. And if I stop the live stream, well, it ends. Cool. So we see the app that we're building is clearly working, which is great. To build this, we will use the Stream Video and Audio SDK that we can handily also use to build live streaming applications. Live streaming applications have a lot of features. There's ultra low latency streaming, multiple streams, co-hosts, WebRTC, RTMP, HLS, reactions, custom events, chat, recording, transcriptions. There's a lot to cover, so we won't cover everything here. If you're interested in any of these other features as well, then please leave a comment below the video. And while you're at it, please like the video and subscribe to the channel. That will help us immensely. But without further ado, let's dive right in. We will build up the project from scratch. The only two requirements that we have for this is Node.js in version 18 or higher and the Yarn in version 1.22 or higher. We will use Vite to set up the project, so let's jump right into the console. I will run yarn create Vite with the name of the project, Livestream Broadcaster for us, and the React TypeScript template. I will now switch into the folder and install the Stream Video React SDK. And while that loads, let's jump into the browser to quickly show you the documentation that we have for the video and audio SDK. So we have plenty of other platforms as well, but we're interested in React. And as you can see, we have a bunch of tutorials. We have a lot of documentation about the core concepts that we have in the SDK, about the UI components that we offer, about building certain UI features on top of that, and even some advanced guides on things like recording, GDPR endpoints, events, and much more. I want to also note that the entire SDK is completely open source, and the repo has seen quite some activity and quite a few releases already, so it's been heavily worked on. And you can take a look at the entire code for this. I will leave the links for both the documentation as well as the GitHub repo in the description of this video. But let's jump back because the installation has been completed. So let's run the project now. You can see it's open on port 5173, and I've opened this. It's been closed yet, and we see project setup is complete. So we can jump to the next step. The next step for us is to broadcast the live stream. And we will start by implementing the logic for this. So what we will do is we will initialize the Stream SDK. Then we will get credentials so that we're allowed to create a live stream. We will then create this stream and join it. And finally, we will start with a container to render out the UI. So let's jump right in. I opened up the project using VS Code, and we see the default Vite project setup. So it's a basic React app. It has an app TSX and some CSS inside of it. So let's close the sidebar and first get rid of all the code that we need. We don't want it to show anything. We don't need the logos. We want to have a clean slate. So let's save it and we're ready to go. Now, in order to initialize the call, we need four things. The first one is an API key. we need to know which project the app is connected to on the stream backend side. Next, we need a user token, which is a JWT that we need to authenticate the user. We then also need a user ID to identify the user, and lastly, a call ID that we can join. The question is, where do we get this? So we have two possibilities. A, we can go to the stream dashboard, or we can just go to the live stream tutorial, which we will do right now, and take a look here. I'll add the link in the description as well. And if you start scrolling down here, we can close this off. We can start scrolling down and we see the same explanations here, and we get all the credentials here. We can also create a free account on the stream dashboard. For the sake of simplicity, we will use these credentials from the tutorial. So let's jump back into VS Code and let's start the implementation. We first get the API key and then the token from the live stream tutorial site. We then add the user ID and a call ID. Awesome. With this ready, we can start the initialization of the Stream SDK. So first we set up a user object with the user ID, a name, cool name, and an image. With that set, we can now create a stream video client using the API key, again, to authenticate the application with the backend, the user that we just created, and the user token to authenticate the user. Then we create the call, and for that we use the live stream type. I will get to what that live stream type means in a second, but let's first finish off the code for this. We also add in the call ID, and then we call call.join, and we want to create it if it is not there yet. With this in place, we can jump to the app and initialize stream video with a client that we just created. And then we call the stream call object. And what these two elements will do, they are essentially providers that will inject all the necessary data to all the UI components that are below them in the DOM. So we will expose a lot of hooks for you to use, and with that we have easy access to all the features, even if we don't want to use some built-in UI components, but even if we want to build completely custom UI. Speaking of UI, we will also add a My Livestream UI component that we create in a second. But first, let's add some imports. First, we want to import the styles CSS from the Stream Video SDK. So you get a lot of styling for free. And we want to import all the components that we are using here. Now, the final step is to create this My Livestream UI component and add a notifier for us that we need to add this UI. We save this, we run yarn dev again to run the project. We switch back and we see it seems to be working. Video is already streaming, but now we want to, of course, also show this somehow in the UI. So let's jump back into VS Code to show our own personal video. So we want to, of course, see a preview of that before starting the live stream. Now, I already mentioned that due to the stream video and the stream call providers, we get a lot of things for free that we can now use. So let's first get rid of this render thing and let's start. We want to have access to the call, so we will use the use call hook, which is convenient for us. We then also want to have access to certain state properties of the call itself. So we want to know, is the call currently live? Do we have local participants, in this case ourselves, and even show the participant count, because we want to know how many people are viewing the stream. And we get access to this using the use call state hooks hook. Okay, we can access the total participants from the use participant count hook, the local participant from the use local participant hook, and finally the is call live from the use is call live hook. Awesome. Now we want to start by implementing the UI. We add a div for a container. We give it display flex and set the flex direction to column and give a slight gap to it. We add another container with some CSS properties to show the live view with a slight blue background and show how many participants have joined the stream so far. Next, we want to render the video of the local participant, so ourselves here. Again, we create a container, and if we have a local participant, which can be undefined, we say we want the participant view with the local participant. We don't want to show any additional UI that would be common for things like video calls. So for example, selecting the camera, ending the call, selecting microphone and other features. We don't want that right now. We just want to see the plain video feed. So we set this to null. And this is an example of a component that we get from the Stream SDK. Last step is to allow us to go live with the stream or end the live stream. So again, we create a container and say if the call is actually live, we add a button that says stop live stream and we call the call.stop live function. Now, if the call is not yet live, we add the button of start live stream and we simply call the call.goLive function. So it's really not a lot of code, but if you think about it, the functionality is quite impressive. We save this. Now, if I switch to the browser, we already see the live one text is shown. We see the beautiful video feed of the local participant. And if I scroll down, we also see the start live stream button. We can click this and it would switch to the stop live stream. Cool. If I stop the live stream, it actually works. Now I think we can all agree on the fact that the only thing to make this demo even better is with lasers. Ooh. Well, no, of course we want to add the viewer as well. But before that, I want to quickly discuss a few of the things that are happening under the hood here that we haven't talked about yet. Now, the implementation took us only a few lines of code, but a lot of things are happening under the hood here. And I quickly want to talk about two of them. The first one is SFU Cascading. We have an excellent explanation of this on our website, and I will leave the link in the description, of course. But what it basically does is it routes each stream through a bunch of what is called SFU, selective forwarding units, and optimizes the streams in a way that every recipient will only receive the relevant streams for them and discard everything else. Now what this will do is it will optimize for the current network state, it will reduce latency, it will optimize quality of the streams that people receive, and there's a lot more going on there. So feel free to take a look at that and read more on it. But you get this essentially for free using the Stream Video SDK. And the second thing is that we used the call type in our application to be set to live stream. But what does that mean? We have a bunch of pre-configured call types in our SDK. Specifically, these are default, audio room, live stream, and development. Now, what does it mean if we use the live stream type? For this, let's jump into the stream dashboard. And we first see that we're now in open beta. So it's the perfect time to check out the SDK and take a look at that. But as you can see, we have a bunch of properties here and we can also access the tutorials and everything here. But we're interested in the call types for now. We see the same reflected here as we have in the documentation. So let's open up the live stream one. And here we can set a bunch of properties. So for example, that video is particularly enabled by default and the camera as well. We can set the microphone on by default. We can configure recording, qualities, layout previews, broadcasting, and also things like Backstage. Now, Backstage is the feature that as a broadcaster, you can already access the stream before going live. That is great to check if your setting is correct. You can also test the stream with other participants if you have them, and much more. And you can enable or disable that if you like. Just wanted to quickly show you that we've only scratched the surface of what's possible. Now with that, we are finished with broadcasting a live stream, and the next step is to obviously create a viewer app so that people can actually consume this live stream. The first question that we have to ask ourselves when viewing a live stream is whether we have a WebRTC stream or an HLS stream. I won't explain the complete differences between the two, but we can think of WebRTC as the more modern version, which is technically faster. But on the other hand, HLS is better under poor networking conditions, but on the other hand, has a delay of around 20 to 30 seconds. So it's a trade-off between the two. There's no better solution. So naturally, Stream, of course, supports both. We will start with the WebRTC version. So let's jump into the code. We will set up a new project, and I will go over this a little bit more quickly now. We will create the same thing as before using Vite and the React TypeScript template. We switch into the Livestream viewer folder and add the Stream Video SDK. And with that done, we can open up the project in VS Code. We open up the skeleton again and get rid of all the code that we don't need so that we have a fresh plate to get started with. Now we already know the drill, so let's add the same credentials as we had before. So we need the API key, we need a token, we need a user ID and a call ID. With that set up, we can create a user, call it someone different, and then initialize the Stream Video client. So far, it's exactly the same code that we had for the broadcasting app. We again initialize the call with the live stream type. You now know what this means. And now we disable both the camera and the microphone because, of course, as a viewer of the live stream, we don't want to have access to this at all. Then we join the call, and for the UI, we do the same dance of first adding the stream video object, then the stream call. And finally, we use a live stream layout component, which is something we get from the SDK for free. And for this, we can say we want to show the participant count, the duration, and whether the call is live, so the live batch. And after adding some imports for the necessary objects, we can save this. We can run yarn dev and go to localhost here. You can see we have our broadcasting app still running. Let's check. It's not live yet, so let's add a split view here so that we can see them side by side. We go to localhost 5174. We don't see anything yet because the live stream is not active. So let's change this. Let's start the live stream. We're live now. Let's refresh. And it's initializing. We see the stream is happening. We see there's 2 people live. Same here. And now we've reached the state of the demo that I've showed you before, which is awesome. It just required a few lines of code to build this fully functional live streaming application. Great job. Well, there's a lot of thumbs here. Now let's stop the live stream. And this also works. The duration stops. Everything works as expected. Now we've seen the example for adding a WebRTC live stream and viewing it. But now we want to also take a look at HLS. What we will do is we will, instead of publishing a WebRTC stream, we will now use HLS for streaming. and we will use a viewing tool to see if it's working. Let's jump into the code. What we need to do is we need to extract the HLS playlist from the stream. So let's see how we can do this. First, we import a new hook called useCallEgress and extract the egress constant from it. Then we use a useEffect hook, and inside of it we lock the HLS playlist URL from egress.hls.playlist URL. We need to depend on the playlist URL, so whenever this changes, we will lock this to the console. And now the last step we need to take is when we call the go live function on the call, we can add a parameter called start HLS is true. With this, the stream will start as an HLS stream, and then we can lock the URL. So let's see how this looks. We have our window again, and now we can call the start livestream button. We will get a stream, and we can now take this, copy it, and switch to a service. We use live push for this, but you can use anything else. We can paste our stream here and hit the play button. And as you can see, our stream is exposed. We see a delay of 10 to 20 to maybe 30 seconds, but the stream is working. We just exposed the HLS from the call to any player that's capable of playing this. Great job. Now let's do a quick summary of what we've built today. We have built both a broadcasting as well as a viewer application for live streaming using React and the Stream Video SDK. We talked about different things that are happening under the hood, as well as some of the protocols that are involved here. We could add even more advanced features such as custom events, recording, chat, reactions, and more. If you're interested in that, definitely leave a comment explaining what you want to see. I think it's pretty cool to see what we can build with only a few lines of code using the Stream Video SDK. And if you're also excited, please like the video, subscribe to the channel, and come back for more content. We'd love that. Have a great day, and bye-bye.